Hello guys, my name is Balkrishna Srivastav and welcome to Code with BK. So in this video, we solve question 9 of 2023 ISC Computer Science specimen paper, which is to create a class holder. So before we begin, it is a request to please subscribe to my channel, because out of 100 views, only 1 or 2 are subscribed and a subscription is very important. So please subscribe to my channel. So let's begin. So whenever I solve ISC Computer Science board papers, I always recommend that you read the question very carefully from the first letter to the last letter. So take a minute and give it a complete reading. Alright. So there is a class holder that has data members these are the functions, and you have to give the details of functions add int and remove int only. Okay. No main function and no algorithm needed. Okay. And you have to assume other functions are defined. Okay. So let me create a class with these data members and the functions which are already defined. So this is our holder class. These are the data members. This is the constructor. I have kept the constructor and show method hidden. I will show these at the end of the code. Okay. And these are the two methods we need to complete: add int and remove int. Okay. So if you look at the question, you are given an array that is supposed to behave as a queue, because elements can be added from rear and removed from the front end only. Okay. This is a queue. Alright, so your answer 2 is going to be a queue. Okay, and the principal is going to be first in first out. And looking at the constructor, you see your front is at 0 and rear is at 0. Okay, so if you imagine this array as something like this of 5 locations. Okay, so your front is going to be at 0 and your rear is also going to be at 0. Okay, the first index. Alright. So if you add int, which is to be added at the rear end, okay, suppose if you add 10, when you add 10, what happens is you are adding to rear. So 10 is added here, front stays here, rear moves forward. If you add again, okay, add 20, okay, 20 is added here, front stays where it was, rear moves forward. Okay, similarly you add 30, okay, 30 is added at where rear is, rear moves forward. Okay, this is adding 30. Okay, you add 40. So you add 40. 40 is where rear was, rear move forward. Add 50. Okay, 50 is added where rear was. Add 50. This is rear moves forward. So rear is now 5. Okay, indices here are 0, 1, 2, 3 and 4. Front is at 0 because we have not removed anything. Okay, so when rear is equal to the capacity, we have reached the limit and we cannot add any more elements. So looking at this holder is going to be full when rear is equal to capacity. Alright, and you have to print holder is full in that case. So holder is full if rear equal to cap. Okay, and in this case you print holder is full, so you say system.out.println holder is full. Okay, and then you return. Okay, else if it is possible to add, what we did was we placed the new value where rear was. Okay, and we removed rear forward. So placing the new value where rear was and moving rear forward. That's what we did when we were adding values to the rear end. Okay, now you have to remove int, and remove is happening from the front. Okay, remove from the front end only. Removes and returns the integers from the front end if the holder, if any, else return -99. Alright. So how do we know if there are no elements to return? So if you look at this is the case when there are no elements to return. Okay, front is at 0. Now let's start removing elements from this configuration. Okay, which is this. Okay, so rear is at index, if I give this indices 1, 2, 3 and 4. Rear is at 3, we have capacity for 2 more elements. But I say remove. Okay, so remove from front. Okay, so we cannot actually remove an array location. What we do is we move front forward. Okay, so we cannot access this location anymore because front has moved forward. Okay, we remove again. Okay, so basically when you remove this, so removed 10. When you remove again, you removed 20 because f moved forward. removed 20. Okay, we do this again, remove again. All right, we can do this because there is still one element at front, so we removed 30 in this case, and front comes here. All right, so this was the point, okay, where there were 3 elements added. Okay, rear is here. This is the point there are no more elements left in this holder. Okay, so the condition for no elements in this holder is rear and front are at the same index. Okay, and that is what it is when the holder is big, empty to begin with. Okay, so I say if rear is equal to front. Okay, if both rear and front are at the same index, there is nothing to return, so I return minus 9 and 9. Okay, if nothing to return, I return minus 9. Otherwise, what we did here was we get the element at front, remove it, and move forward. Okay, we cannot actually remove a location, we just return it. So I say int removed element, okay, is q of front. Front moves forward, we return the removed element. Alright, so remove int is done as well. Okay, so this is my code for addint and removeint. So let me add some code in the main. So I have created a holder object that can hold 10 elements. Okay, I show this holder object. So initially to begin with it is empty. Then I add 18, 3 and 12. So adding 18 to the rear end of an empty queue. So if the queue is empty and you're adding the first element, then it becomes the element at the front and it becomes the element at the rear because they're the only element, right? Then we add 3 at the rear, then 12. So let me show you the show function now, okay, and the constructor now. Okay, front and rear begin at 0. Okay, compiling this, running this. Okay, so when we begin with an empty holder, it shows blank. Okay, this is the front and rear end. When you add 18, 18 is the only element and it is the element at the front and rear. When you add 3 again, it goes to the rear side, so 3 and 18. When you add 12 again, it goes to the rear side. Okay, adding from the rear end only. Now if I remove, I say system.out.println removed element, okay, plus holder dot removeint, okay, and I show again. So the element now will be removed from the front, so 18 is going to be removed first. So compile, run. So 18 is removed first. Then I do this again. Okay, I get 3 removed next. Okay, compile, run. 3 is the next element. Oh, I did not save this. Compile, sorry, run again. Okay, so next element moved is 3. Okay, adding from the rear, removing from the front. All right, so if I add couple of elements more, so if I add say 27 and 1, okay, adding 27 and 1 to this state, so basically 12, then 27, then 1, okay, because adding from the rear end, compile, run, 27 added, then 1 added. Now if I remove again, okay, it will, oh, let me save, compile, run. Okay, remove 20, remove 12 at the front. I can remove 2 more elements. Okay, so adding this twice more, compile, run. Okay, holder becomes empty. If I do this again, I get minus 999 because there is nothing to remove. Okay, and I will get the same minus 999 if I try to remove, okay, from the empty holder. Okay, my first statement. So you see I get a minus 999 for empty. Okay, so I will add 10, 20, 30, 40. Okay, because the capacity is 10. I'll say compile, run. Okay, now if I try to add one more, I get a holder is full message. Okay, compile, holder. Oh, what is the capacity? Capacity is 10, so I have added 18, 3, 12, 3. Oh, 3 to 5 elements only. Okay, 5 elements. then 5 more elements. Now if I try to add one more, okay, it will show me folder is full. Okay, and this is because when you are adding, right, rear is moving forward. Okay, rear is moving forward when you are adding. Okay, once, and there is no way rear goes back. Rear can never be rear minus 1. So once your rear reaches the end, the holder is full, and once your front also reaches the end, the holder was full and then it became blank. So you cannot add any more elements even if you're not using any of the locations, because that is how the question is framed. Okay, so this was the solution to this problem, and I hope this was helpful. And I will add the link of the code to this problem in the description as well. And I've also solved this problem in Hindi on the whiteboard, explaining in detail how basically this holder works. Okay, I will add the link of that video in the description as well. So this was the solution, and I hope this was helpful. So please do like this video, share my video, and subscribe to my channel. And please let me know in the comments if there was something which was not clear to you in this video. And if there was something that you did not like about this video, please just don't press the dislike button. Please also let me know in the comments what was it that you did not like about this video, so that I can improve in my further videos. And you can always let me know in the comments if there is a question you want to solve or if there is a concept you want to discuss. Thank you.